I remember the first time when I saw this problem reverse linked list and thought, wait, how do you even go backwards if linked list only moves forward? It felt confusing at first, but once I figured it out, it all started to make sense. If this one been tripping you up too, don't worry, we'll go through it step by step together and I show you how to get that. Let's make it finally click. So, what exactly is this linked list? Imagine you're organizing your epic movie collection, but instead of shelves, each movie is in its own box. And the only way to know what movies comes next is a little note inside the current box. That's kinda what a linked list is, a bunch of individual notes pointing to the next one in line. And what is reversing it? You have to literally go into each box, change the note to point to the previous movie, and then make sure the last movie now points to nothing, becoming the new first. It sounds like a pain, right? Well, it could be if you don't have a strategy. Let's look at the actual quest objective. We are given a linked list. Our goal is to turn it into that one. Each list node holds a value and the next property, which is super important because it's the actual link to the subsequent node in our list. If next is null, it means we have reached the end of the chain. How do we tackle this linked list problem? We need 3 key pointers. Current is our main explorer, the node we are currently examining. It starts from the head of the list. Previous is super important. It remembers the previous element in a list. At the beginning, previous doesn't point anywhere, so it's equal null. Now the real magic happens in a loop, where we venture through each node. On every step, we first save the next node in the next temp. Then we make the current node's next pointer point to the previous. This is a core reversal, literally flipping the direction. Immediately after, our previous marker catches up to where our current pointer just was. And finally, our current pointer advances to the next temp node we saved. We repeat these operations node by node as long as current element exists and doesn't equal null. So after all the operations, we end up with a new list that's reversed. And notice previous now points to the first element of this new list, which means it becomes a new head. Alright, enough planning. Let's translate this strategy into robust TypeScript code. We start by defining our function reverse list, which takes the head of the linked list and promise to return the new head of the reversed list or null. We initialize a previous variable. It starts as null. Next, we create current pointer that starts as a head of the original list. Now we loop through the list as long as current is not null. This means we continue until our pointer has traversed the entire original list from beginning to end. Next, we create next temp and save here a reference to the original next node. Now we reverse the direction of the nodes and set current next to point to the previous element. And after it, we are shifting our positions of previous and current. Previous is now where current was, and current moves forward to next. Once the loop finishes, current will be null. At this point, previous will be pointing to the very last node of the original list. So we return previous as a result. Now for the resource management part of our quest, complexity. On the one hand, we traverse our list only once, so the time complexity is big O of n, where n is the number of elements in the list. On the other hand, we don't use any big data structures, so the space complexity is big O of 1. Super efficient. And there you have it, the Leetcode problem reverse linked list conquered as a part of our code quest. Hopefully it made perfect sense and now you feel like a linked list master. And now if you want to solve the most popular problem in the world, every coder faces, then this video is your next stop.